Sigfox. This is a LPWAN technology that uses UNB, ultra narrowband modulation. It is suitable for low data rate, lightweight devices based on IoT services. The typical structure of the modulation is dBPSK, and it is at low bit rates. Overall, the high base station receiving sensitivity is required. Small and lightweight messages are what are transferred over Sigfox networks, with a uplink maximum of 12 octets for payload. That's 12 bytes. Uplink means that the sensor nodes are sending to the overall Sigfox base station access point. Their packet sizes are limited to 12 octets, 12 bytes. And that is for the payload, meaning that the overall packet is going to be larger. However, the information that you can put into a packet, which is the payload, that is limited by 12 octets of a size. In addition, downlink max is 8 octets for payload. What is downlink? Downlink is from the LPWAN, the Sigfox base station or access point, the master node, sending it down to the sensor devices. That has even a smaller packet size, where the payload, of course, is smaller at 8 octets, 8 bytes. And it has a 14 octets for the header. So looking at this right here, the maximum of 140 transmissions per day with a data rate of 100 bits per second is typical what the service is thought about. Sigfox uses license-free ISM band, and the ranges that are used are the 800 MHz range in Europe and the 900 MHz range in the United States. These frequencies are ISM band frequencies in which their frequency characteristics are very well penetratable through solid objects. Number two, they are at sufficiently high frequencies such that their antenna sizes can be small, meaning that the Sigfox devices do not have to be large. In addition, at these ranges, there are other signal propagation characteristics that make them very attractive. In addition, other devices that can connect to them can be easily designed because there are abundant modem chips and RF circuits and antennas that exist at this range. Looking into the Sigfox operation, the network architecture, we have Sigfox objects. That means that they're objects, but they have Sigfox modem chips on them. Then there's Sigfox stations. These are the base stations, access points, that are picking up signals from these objects that have the Sigfox modems on them. Then there's a Sigfox cloud, and the cloud itself is a trademarked item that you see with that symbol, and customer IT applications. Then, each Sigfox device and station has a unique Sigfox ID, where the ID and its signature are transmitted for authentication of each device. In terms that each device has an ID and a signature, and that is transferred through the Sigfox stations to the Sigfox cloud. And that is where, once again, authentication is conducted. And this is done on for each device. Each device is identified and it is authorized individually. The objects that sense data will send their data to the Sigfox station, and the stations will send directly to the Sigfox cloud. When the objects send their signal to the Sigfox stations, then the Sigfox stations will detect these signals, demodulate the signals, and report the messages to the Sigfox cloud. The cloud will push the messages, will send the messages to the user application or the customer platform. And this is how service is conducted. These are the references that I used, and I recommend them to you. Thank you.